In this video, we will be learning what function notation is. In algebra, sometimes it's more convenient to use function notation as opposed to just perhaps non-function notation. Sometimes it's nice to write the equation like y equals x squared, but other times it's much nicer to write it as f of x is equal to x squared. I want you to think about that f of x, what goes in here is the input, much like this machine. So it says, what are we putting into the machine? This tells us what to do with that, and then we have an output. So if we put in 3 for x, we would say 3 squared, which is 9. Here, if we have star, we would have star squared, or theta, theta squared. This symbol, that symbol squared. So the idea is whatever is inside these parentheses next to your f of something, that is what that something is going to go in place of x. So let's take this function. This is a function, or we would not be able to use function notation. And that function is f of x is equal to 2x plus 1. So again, what we want to do is we want to, wherever there's an x, those things are going to be the same. So we're going to be asked to find f of negative 2. So f of negative 2 equals 2 times, and I think that's the best habit you can get into, is put parentheses in place of that x and then fill that parentheses in with whatever was over on this side of the parentheses. So we have 2 times negative 2 plus 1. And then just work on the right hand side. So we have negative 4 plus 1, which is negative 3. So f of negative 2 is negative 3. Let's try it again with 0. So f of 0 equals 2 times 0 plus 1. So f of 0 would just equal to 1. Hopefully you're kind of getting the idea. So numbers are pretty easy, but we can also do it with letters. So we would have f of a equals to 2. Now remember, wherever that x is, put those parentheses and kind of look at it as fill in the blank. So I'm going to put that a. Well, you can't do much with that. That's just 2a plus 1. And that's what f of a equals to. Our next one, f of a plus h. So f of a plus h equals 2 times, what are we going to put in that parenthesis? In place of that x, we're putting in a plus h. And again, not much else you can do with that. We could maybe distribute that too. But since there's no like terms to collect, we would have to leave it like this. Now one thing you have to remember is we're not solving any equation. We're just really evaluating an expression, if you will. But let's look at this. Oh goodness, that has a lot of parts to it. Alright, so I want to look at each part. One part is f of a plus h. Well, we just did that. The next part is f of a. Well, I think we did that over here. Now what do we need to do with those things is we need to subtract it. And then the third and final thing is we just need to divide by h. Now notice that's not f of h, that's just h. Okay, so I'm going to take some of my previous work to help me save some time here. So here's the problem. So f of a plus h is what I've highlighted in yellow here, so I'm just going to write that down. And then here's the tricky part. You want to subtract, and anytime you have a minus sign you want to be careful, so I want to put parentheses there, and then I'm going to say, well, what's f of a? Well, that's here. That's 2a plus 1, and I want to make sure I subtract all of that divided by h. Now I am going to go ahead and distribute that minus. Then hopefully you can see there's some like terms. Let's see, 2a minus 2a is 0. 1 minus 1 is also 0. So let's see what we have left is 2h divided by h. We also can reduce that as well because the h's divide out. And my final answer is just 2. So from this big conglomeration of stuff, we just got 2. Now let's do the same thing with this function, but notice the x is squared, so we're going to have a little bit more work cut out for us. Alright, so I'm going to start out with the numbers. G of negative 2 equals 2 minus, then put that parenthesis, negative 2 squared. We also have to be really careful with our order of operations that we want to square this negative before we subtract. So that's 2 minus 4. That's negative 2. So g of negative 2 actually equals negative 2. Purely coincidental. Alright, so let's try g of 1. So we have 2 minus 1 squared. So that's just 2 minus 1, which is 1. Okay, I'm seeing a pattern, but again, I'm pretty sure that's coincidental. So let's try g of a. G of a is 2 minus, and in place of x, we're going to have a squared. That's all you can do with that. There's no like terms. Now, g of a plus h. This one's going to involve a little bit more work, but the concept is the same. So we have 2 minus a plus h squared. Now we're going to need to square that out. I'm going to take it step by step. 2 minus a plus h times a plus h. So I need to FOIL this out. There is no shortcut to this. So 2 minus, and since I don't want to lose that minus sign, I'm going to put a parenthesis. Alright, so a times a times h times a, and I'm going to put that in alphabetical order, and then h times h. Notice those are the same, so I'm going to add them together. And notice how I still have that in parentheses because I don't want to lose that minus sign. So now I'm going to be very careful, and I'm going to distribute my minus sign. And that is what g of a plus h equals to. So now we're going to put some of these together. Again, we want to use some of our previous work. And so I want to find g of a plus h, which is all of that. And then I want to do g of a, which is this one. And then the last thing I want to do is divide by h. So g of a plus h is everything I highlighted in yellow. Minus, very important, this minus, very important. We want to subtract g of a, which is what I've highlighted in green. And then the last thing I want to do is divide by h. So let's distribute this minus sign. And let's start seeing if we have like terms. So 2 minus 2 is 0. Negative a squared plus a squared is also 0. Let's write down what we have left. Now notice they all have an h, so I can factor out an h at the top. And then I can reduce those h's. So my final answer is negative 2a minus h. You just need to be careful, especially with all those minus signs. But the idea is, if you have that function notation, f of x, that of part, parentheses, replace those x's with big parentheses as like a fill in the blank.